I'm not sure whether I should feel embarrassed about this or whether I should be enthused by Ron being the one who's leading this session, because it was it 4 or 5 years ago when you had the whole group from Barry come by at this same conference. It kind of gave me the idea that we need to be thinking about IBL and more ideas than just in a mathematics course. And I'll show my background and you'll see why I might think about that. Okay, so starting, I have an interesting background. Some people have called it interesting, others have called it brave. Stupid is another word that gets used. My undergraduate was at Wake Forest, where I got a major in mathematics. I did a master in pure mathematics at Indiana University. My doctorate's in algebraic geometry from the University of Georgia. After 4 years, I then went and got master degrees in Germany in economics, and in France in finance. And that probably tells you a thing or two. In those 4 interim years, I was at Western Kentucky University. It's a directional state university, 20-something thousand students. It's a large, trying to serve students who otherwise might not go to college. Then I taught in Paris, both as a student working on that master degree. I was teaching the first year master courses in the mathematics. And then I've been back to teach in a summer, and we'll go into that later. When I came back to the US, I spent 5 years at Wingate University, which is a small liberal arts school of about 2,000 students. I spent some of the summers at UNCC, where I taught in an engineering department. That's another large university, but it felt small because I was teaching master level courses to engineering students. And then finally, I've been at Rose-Hulman for the past year. It's a small engineering school, about 2,000 undergraduates. The great thing is there are 25 mathematicians there for 2,000 undergraduates. Every student is required to take 6 quarters of mathematics, so we see a lot of them, and we have the opportunity to try some things. All right. So what was my experience? As you see, as a student, there were only 3 courses I took and using IBL, but it was something these were all modified Moore method, in fact, and they were things that really affected me. So I said that if I get to the point where I have students, this is something I should do. I understand these topics at a much deeper level. And so I've done that. Starting at Western Kentucky, when I just finished my dissertation, I had a few courses that I taught using IBL methods. Now these may not be completely Moore method courses. The first speaker in this session talked about how there are some courses that really fit well for Moore method and some that don't. And some of the things that I've been doing don't. There may be some lecture components to it, but I also want to make sure I have that inquiry at different points in the semester or where I am now during the quarter. And you can see then at Paris, in Paris, I taught 1 course about 3 summers ago, and I tried to do that with IBL, and I stress tried. I'll talk about their ideas on education when we come further. At Wingate, they allowed me to teach a lot of the upper level courses, which meant I got a great opportunity to teach using modified Moore method, most of them, except for the game theory course, which was really a course within a course that we had on, I called it math appreciation, because there really wasn't a lot of math being done most of the time. Like in a music appreciation class, you don't construct music, you actually just listen to it or watch other people do it. It was the same thing here, that they had a lot of the students just watching a professor do math and then not really do any on their own. And I decided I was going to change that around and teach them some things about strategy and about game theory. Then at UNCC, I taught the engineering stats courses, mostly using IBL. And in the next quarter, I'll be teaching a couple of courses, and I will be using IBL, including statistics, which I think is a good idea for IBL, but maybe not for a Moore method course. So I've been lucky to get some AIBL mini grants. I'm very thankful to the Academy for Inquiry-Based Learning for allowing this. The first one, I started trying to talk with faculty at Wingate University about doing different things in teaching. Starting kind of on the, let's just talk about how we teach, and later having my own agenda, which is we need to teach the students how to think. It's kind of like what Starboard was saying last night. We need to teach thinking, and we can do that beyond mathematics courses, although math is a very good place to do this. The allies I found were in the business school. I taught MBA courses also because of my background, most of the quantitative courses, and I found some allies there because they're used to doing case studies. They're used to doing those kinds of things, which if you just say push it a little bit further and let the students discover, that happens. And then chemistry also, mostly because of the POGL program. I found a few allies there. Here I have Barry, a colleague of mine who also taught the quantitative courses in the MBA program. Barry's quote was a great one. When I asked him, why don't you come and talk with us about teaching? You've won some teaching awards. You're a good teacher, obviously. And he said, why would I consider these methods you're talking about? I got this job by lecturing. I've won teaching awards by lecturing. I'm pretty damn good at what I do, so why would I change? Right? That's an appropriate kind of question. It's one we've got to be able to answer. We'll come back to that later. I also opened up the classroom. I think I was teaching linear algebra the first semester and real analysis the second semester. And I continue to write the campus. That's a great thing about this faculty listservs, especially at a smaller school. You can harangue people by sending out messages, right? And say, hey, why don't you come see what we're doing in this class? One person from computer science came by, thought it was to see what was happening. And then there was also the guy from chemistry that I mentioned before about POGL. In fact, he wanted to take part in the class the one time he came to visit, and the students were way too kind to tell him he wasn't doing things correctly. And so, I mean, they'd be all over one another, but if a professor was doing something in a mathematics class that wasn't quite right, they were a little bit deferential. And so it was an interesting experience and maybe a good social experiment, I don't know. The second AIBL grant, and here I'm going to throw some pictures in just because bragging, I guess, I don't know. I went to France to teach about 3 years ago, and I wanted to teach this course in probabilistic and statistical methods in finance, and I wanted to do it by inquiry type methods. The thing you should know, do many of you know the French attitudes towards teaching? Okay, so I see Joy Adi's the only one shaking her head. Because we were taught, okay, so that's it. I can remember in a course when I was a student in Paris, there was a 2-hour lecture, and in 2 hours I asked 7 different questions, right, because I didn't understand. That was the whole thing, and so I did. And it's customary, very differential to the professors there. The professor leaves first and the students leave. And so after the professor left, I apologized to all the students, and I said, I'm sorry, I must be the only one who doesn't understand. And Sammy, a good friend of mine from Paris, said, no, Wayne, you're the only one who understands well enough to ask questions. And I said, Sammy, why in the world aren't you asking questions? And he said, because then the professor would know that we don't understand. And I said, well, there's a final exam coming up. It's going to be pretty clear. And the look on his face of realization was really a good one, I thought. But it's one of those things, the professors don't usually have office hours, and if they do, they don't intend for you to come by. They may not be there during office hours, in fact. But it's a system where questions are not asked. So I utterly failed on this. I had one good situation. I had one of my undergraduate students working on me with research that spent the summer there, and he was my plant. He was taking an upper-level master course as an undergraduate, but he would answer questions. He would talk. He would try to do some things, and between the two of us, we didn't get much accomplished. This is the building here where I taught, and this is the view from my office. This is the Sacré-Cœur in Montmartre, so I thought, it's great. You should go teach in Paris. It's a good thing. So what kind of issues have I encountered in trying to get other people to think about using inquiry-based? The first one that I come about is that they have attitudes about teaching. Barry, for instance, said, I'm doing a pretty good job. Why would I do anything different? And I said, well, Barry, what if your students could learn more or learn deeper items? And Barry was there every time we met because he's that good of a teacher. He said, well, okay, so let's try this out. It's going to help my students. So if we can approach those kinds of issues by having the dialogue, I think that works. I think that's what I'm writing here. Inertia is another one. I've got my class notes that I started 35 years ago. Why would I change them, right? It means I have to do more work. Cultural issues, dealing with the French, right? Dealing with other kinds of topics. I'm in an engineering school, and the culture there is we have to cover Calculus 1 in 10 weeks. We have to cover Calculus 2 in 10 weeks and Calculus 3 in 10 weeks. And so over the course of that first year, we have to get through all of one variable and multivariable calculus. And so the culture is we have to be fast, and we don't have time to stop and think about it. We just need to finish it. In fact, on one of my differential equations, I taught a DE1 course this past year, and one of the students wrote, because I was trying to do some inquiry-based things, even though I wasn't doing a lot of it, I tried to do some inquiry-based things. He wrote, "This is a subject that's been settled for 200 years. We trust that the people who did it know how to solve it. We don't need to understand why. Just show us how to use this." Yeah, and so all of you are cringing like I did. And I'm sure this was meant to be a complaint, and my department head and my dean have both said, keep doing what you're doing, right? Because if you just change those problems slightly, those methods may not work. Not understanding that's going to be there. And then questions about covering material. Do you cover as much? Can you get through the whole syllabus? Is it possible to do this or not? So the discussion helped me in trying to address the concerns. Resources like the journal, if you're talking with mathematicians, the Journal for Inquiry-Based Learning in Mathematics has helped me a lot. I've stolen Ron Taylor's notes in the past. Of course, he sent them to me and then wanted comments, but I've stolen behavior's notes. I've stolen several people's notes, and I've made sure to write and say I'm using them. That's all that's required. But if you're dealing with mathematicians, those kinds of resources are great helps. I'm open to suggestions about cultural issues. Right? How do you deal with these kinds of things? I don't really know. And then as far as the material, I demonstrate that we cover this stuff. In fact, most people think of their courses being in a linear progression. For mine, when I use inquiry-based methods, it's almost like it's exponential. And you're all shaking your heads because it's the same thing for you. You don't have to go back over those same issues at the beginning because the students have actually internalized them rather than just dealing with them and not really understanding. So you've got to explain it a second and a third and a fourth time. If not in class, then during office hours. Right? So I think applied mathematics is another place to use inquiry-based methods. Right? Maybe not the Moore method, as the first speaker in this session said, but to use inquiry-based methods. I consider many things to be applied mathematics. That's maybe egotistical, but we're among mathematicians mostly, so we can get away with it, right? Engineering, a lot of it's applied mathematics. Economics is a place I have a degree, and so I think of that. Applying statistics, dealing with the experimental sciences, and computer science, each of these, I think, have applications that we can use. And that IBL then should work naturally in each of those. I'll demonstrate how in one issue that I deal with. So why not have us be the ones that take these to our colleagues? Why not be the ones who say, your students will understand better if you don't tell them how to think, but instead encourage them to think for themselves? So one example for me, my research area is in risk measures. I've got many non-math colleagues. I deal with people who have degrees in finance and degrees in economics, and they understand almost no mathematics. Maybe that explains a lot about the situation in the world today, right? Is that these people who are making financial and economic decisions for our world don't understand mathematics. So they don't understand this area of risk measures either. Students are also asked, if you're going to approach risk measures, there are about 3 textbooks and they're all at the graduate level, but there's nothing difficult about risk measures. Right? Most of the times you start with, now since you all know stochastic calculus, we can use these tools in order to describe things. And it's entirely unnecessary. And so what we can do instead is we can use, I think we can use inquiry-based methods in order to help students understand. So in a text I'm in the midst of, this is one of the ways that I try to draw on students. Others have said it, I agree with it completely. When you begin a course like this, you have to think easily to begin with. Right? You have to think about easy questions to draw them in. Because if you start asking them to prove the continuum hypothesis on the first day, you're not going to get anything and they're going to rebel. But if you ask them easy questions and you ask them questions that seem like common sense, you start to get their participation and they start to buy in. And so this is the one that I start with. This is a picture of John Steele at the church at Santa Maria Eglise, if you know, like from The Longest Day or something like that. Beautiful place. So again, just using the pictures that I have. So this is the question that I ask. If you're going to go skydiving, which of the following situations involve risk? I mean, first we have to define risk. Later we can figure out how to measure it. So if you're standing safely on the ground after you've already gone skydiving, is there any risk? Right? If you're in the airplane and you're about to jump, is there some risk? Right? If you already crashed, right? Like Steele did here. Is there any risk? Right? And so we get them, and it usually has to go through a series of 3 or 4 because most of the time they'll say the last situation is a situation of risk. You took the risk and you lost. I mean, that's what they say. And it takes a while for them to understand, just in walking across the street, there's risk. But once you've already crossed the street, or once you've gotten hit by the car, there's no more risk because there's no uncertainty. Right? You have to have both an exposure to some sort of a pain, whether it's financial or whether it's physical in these kinds of cases, and you also have to then have uncertainty about it. If you're already in the situation of having the pain, you don't have risk. And the question is, how do we measure it? That's what we try to set up. So for me, then, I have to go through those situations of trying to get them to come up with a definition for what do we want to measure, actually. So when you deal with applied mathematics, there are not necessarily these natural definitions that you might have, right? A group has to be a group, and it has to be defined this way in order for other things to work. Now, in applied mathematics, that doesn't necessarily have to be the way, especially when you're talking about behavioral situations, or when you're talking about maybe in chemistry there have to be certain definitions, right? Boyle's law has to work the way Boyle's law works, but you can invite students to discover that by doing experimentation, and that's maybe a problem-based, but it's getting towards inquiry in my mind. So how do we get them to do this? And for me, it's asking these leading questions. They may not get the standard definition to begin with, and that's a great situation, in fact, because we talk about why don't you have the same definition that some author has? Or if we find that an author has a definition, why are they defining things differently? What have they thought about, or potentially what have they missed? What's the author missed that the students are getting? That's always a great situation too. And so that's one thing. Now, there are a couple of other places where I've tried to take inquiry-based learning. Here's a picture of my family. I do this because my wife and I homeschool. Her master's degree is in education, and so we have our kids at home to teach them. With 5 of them. You're saying, yeah, God bless her. She's at home with 5 now. Actually, one of my former students, who's now going to be a PhD student at Johns Hopkins, is there to help her. So don't feel too bad. Feel bad, but not too bad. And so we ask our kids questions all the time. Our dinner table is like what Mike Starbird said last night. Right? We have these kinds of things. I took my oldest 2, so that's Joseph here and Bethany here, on a mission trip to Honduras. And on the airplane, my son wanted to talk about, he's 10, he wanted to talk about solving algebra problems. He annoyed the heck out of a lot of the other people on the plane, but he wanted to talk to me about how can we solve these problems. And so we're just starting to talk about algebra because he wants to be able to figure things out. When we go to museums, it's great because he'll always ask docents questions. My daughter does exactly the same. How does that work? How is this? Of course, it's not good when they get into arguments with some of the people. He had read Columbus's diaries that had been translated, and one of the others were making some things, and so he got into kind of an argument. We had to pull him away. You're 8. You can't argue with these people. But nonetheless, he's asking questions. And so we've got homeschool communities near where we are. And a lot of the people ask, how are you getting your kids to ask these questions, to do these kinds of things? And we say it's just a natural extension. It's something, as a teacher, it's something that we do naturally. And so we live it. And this is the way it's been for me. The biggest fear that most of the people talk about when I say maybe you should try this is, what if they can't answer the questions? And I say that's the perfect situation. Because then you can model for your children how you go about trying to find answers, how to think through things. You get to model for them, I don't have all the answers, but we can go through and try to find the answers, and we can do this together. And so this is something we've tried to do, and for some of the co-ops that we have, I've taught about these kinds of things to try to help parents to have the confidence to realize they can do this, especially with children. Okay. One final thing, I have to mention my neighbor, Mike Keys. My wife also has an undergraduate degree in horticulture. And so when we moved most recently, we went from half an acre to 15 acres. We've got like 20 apple trees now. My son has 17 chickens, and he's learning all about how to take care of them, those kinds of things. However, there are these issues like this. You can see this is me here, and this is my neighbor Mike, and this is my son Joseph. And I was struggling to get my tractor to run. And my wife, Julia, finally called Mike and said, you deal with these things all the time. Can you come and help him? Can you bail him out? And Mike said, well, I've heard Wayne swearing over there, but he hasn't wanted any help, so I haven't wanted to do anything. So, yeah, I'll come over. And he said, then the final words that he said to her were, know this, Julia, I'll let him flounder, but I won't let him sink. Now, he won't say that to me at all. He'll never come and talk to me about it, but he wanted to reassure my wife that we're going to get this thing working. It's going to be okay. I'm going to let him struggle with it and learn. And he does. I mean, we talk about, okay, this is a part. What should it do? What's going to happen? What if there's a problem with it? If you've got this problem with a tractor, what could go wrong? And so we've gone through this exactly. And so what I found is that on my way to trying to teach with IBL methods, it came back to bite me. I got taught by IBL methods by my neighbor. He was in management for many years and continues to work in town, but knows things that I don't know, and he wants to make sure that he's in his 60s. I just turned 40 last week, so and 20 years from now, he may not be around to help me with these things, so he wants to make sure that I can be self-sufficient enough to handle the problems that come about. And I thought about that, and that's exactly what I want to do for my students. I want them to flounder. I want them to fight with this stuff and to try it. But I want them to do it not just in this class, because I want them to learn how to think. And if we have allies in other departments, whether it's an engineering department or a physics department or economics department, who are doing exactly the same thing, then it becomes a part of their culture. And if it becomes a part of the culture that the students understand, maybe we get better student reviews at the end, like we just had in the last talk. There'll be better student reviews about these things actually do work, we're for them, and we're used to them. And this is the opportunity I think we have, is to take this to others, just as it was taken right to me. So if there are any questions, I'd be glad to talk about it. Yes.
I'm Sarah Bleiler from Middle Tennessee State University. I'm really interested in how you use discussion with other faculty to address attitude issues about teaching. Can you talk a little bit about how you actually facilitated those discussions?
We're very open. The different places where I've been have been very open, and you just walk into somebody's office and you start talking to them about how they're teaching and how things are going, and then you can guide the conversation, or they can, or maybe it doesn't come up the first time. I think it has to be that we have this kind of relationship. Barry was the one that I did best with, because Barry and I both taught those quantitative classes. We had something in common. I asked him how it went in the last year that he had taught. I told him about what had been happening in my year and how the students were doing better on the common final we had given, and maybe this is a good thing. So I think for me it's having the relationships and then taking the evidence to it. Is that what you've tried?
Yes.
Or have you tried?
Mm-hmm.
Do you have other ways?
Well, we've started a group at MTSU, and we would talk about particular articles. We may bring in an article and have faculty come in, both from math ed and mathematics, and we find that that's a nice discussion point too, having those two communities together and sharing insights that way. So I was just wondering.
Have you invited people from outside, math and math ed?
We haven't, not yet, but that's another great idea.
Okay.